Hello, and welcome back to the second session on slip velocity. In the previous session, we had discussed about what is slip velocity and how we are going to calculate slip velocity. So, slip velocity is velocity of a drill cutting which is traveling in a wellbore. We need to determine slip velocity to know the whole condition, whether it is properly cleaned or not, whether the cuttings being generated are taken out of the hole or not. So it is a determining step in knowing the in preventing the stuck pipe and ECD, equivalent circulation density, and hole gauge, hole diameter. So we are calculating the slip velocity. In the previous video, we had discussed about there are two methods, and this is a method one which we are going to discuss, and this is a step two. In the first step, we had calculated the angular velocity, and in the second step, we are going to calculate the slip velocity. The slip velocity can be calculated by using this formula. This is a step two, and this is a slip velocity. We are calculating Vs. Vs is the cutting slip velocity, and this is the formula which we are going to use to calculate the Vs. So PV is a plastic viscosity. It is calculated in Cp, which can be determined from fan Vg viscometer. So we can discuss about this topic later, but to be precise, plastic viscosity can be can be calculated from fan VG viscometer or a rheology test. It is measured in Cp, and plastic viscosity normally denotes the solid contents present in a drilling fluid. So that is PV, and we have mud weight here, which can be calculated from mud balance, and it is recorded in PPG or SG. PPG. Now, DC is the diameter of cuttings in inches, and we have density. Density is the density of cuttings in ppg. So, by calculating all these, we'll be getting all these data from the question. So, by inputting all these data, we can calculate Vs, which is cutting slip velocity. So next is, so after calculating Vs, we'll be going to calculate net rise velocity. What is net rise velocity and why we need to calculate net rise velocity? So before proceeding to what is the why we need to calculate net rise velocity, consider this to be a well bore, and this is a well bore, and this is BHA, and this is drill bit. This is drill bit. So we can see, observe this through the drill bit nozzles, the mud is being circulated into the annulus. So this drill bit is generating drill cuttings. These are the drill cuttings, and these drill cuttings need to be transported to the surface through annulus. So this is the cutting. So this cutting travels with a velocity in the annulus which is called as a cutting slip velocity. And the fluid which is flowing in the annulus, it is the velocity of the fluid is annular velocity. So due to gravity, this cutting traveling in the annulus tend to fall down due to gravity. So what is the importance of net rise velocity? So what is the importance of the net rise velocity? So net rise velocity is the difference between annular velocity and and slip velocity. So this is equal to annular velocity which we got from first step, and Vs which is slip velocity which we got from the second step. So if we get annular velocity in net rise velocity in positive, is positive, then we can say that annular velocity is greater than slip velocity. This means the cutting is taken to surface. Okay, so if net rise velocity is negative, this means slip velocity is greater than annular velocity, so the cutting will fall down to the wellbore. So this cutting falling down into the wellbore causes cutting heaps. In the first case, if annular velocity is greater than slip velocity, cuttings will be travel to the surface. If in the second case, if net rise velocity, which is the difference between annular velocity and slip velocity, is negative, then the cutting will be trained to fall down. So this is the calculation which we are going to use for the knowing the behavior of a cutting slip velocity. So good hole cleaning always should ensure annular velocity greater greater than slip velocity. So in the next session, we'll be taking an example problem, and we'll calculate the slip velocity. Please do watch the next session as well. Thank you.